Okay, so the first thing is to know how to read the coordinates properly, because if you do not know how to read the coordinates properly, you're not going to be able to solve this properly, obviously. And also to be able to visualize it. Okay, so you're given that this is a rectangular base of ABCD. AB is 8 cm. So BC is 4 cm. Typically, the top side ABC is square 2 cm parallel side. The center of top is vertical above. Okay, so it's exactly vertical above it. So like I have expected. So BC is 4 cm. So in other words, this is 4 cm. Just label it. This is 4 cm. This is 2 cm. Okay. After which you have square of sides 2 cm. So can you imagine that the base is actually the base of this shape, right? It's actually a rectangle. Then after that, as you go up, it narrows up to a square. Top is a square, right? Yeah. EFG, the top side, it's a square of 2 cm. So this is 2 cm long. Okay. So I need you to understand it's actually this side here. This is 1 cm. 1 cm. So this is actually like parallel to this side here if you want to know how it looks like that. Okay. This is 1 cm. So it's 2 cm. So obviously this is all 1 cm. So the height is HCM. So in other words, this side here, this length here, is HCM. Okay, so this side is HCM. We all know that this is height. Okay, this is height HCM. Now you need to know how to read read the coordinate system. Just like how you learn how to read the coordinates in a two Cartesian form, now you need to learn how to write. So this is how many units? This A to B is 8 cm. So this is actually 4 cm. This is 4 cm as well. So this is actually 4 cm here. 4 cm. Okay. So this will be plus 4i, right? Because this is a plus I unit. So now read how to find the OB. Yeah. OB will be 4i, then after which this is negative 2j, right? This is negative 2j unit, right? So negative 2j plus 0k, because there's no elevation, is on the bottom floor. Okay, please know how to read this. So this is actually just ijk OB. After which you have got, you need to know how to write, this is OB, right? Then OG. OG would be you, okay, this is hard to see, but let me explain. OG would be you move 1 unit here, then after which you go up here by HCM and you go down here. Actually also okay lah. You go 1 cm here, 1 cm down, then go up by HCM. Also okay. It doesn't matter whichever you start. So OG would be 1i minus j, because minus 1j, or I minus 1j, 1i minus 1j plus hk. Okay, so this is actually 1 minus 1h. Please know how to read all the coordinates out. Please know how to read all the coordinates. Okay, I'm only using B and G because B and G is the only 2 points that I need. Show that the equation of line BG. Oh my goodness, this is 1 mark. You should at least give 2 marks, right? This is not fun. Okay, this is 1 mark. Sorry for that. Okay, this is 1 mark. Then we're just gonna. This 1 mark is very cruel though. Okay, at least this is showing, meaning to say, if you know that if you're wrong, you know that you got wrong the coordinates, just to make sure. So this is, maybe I use GB. GB is easier. So this is 3 minus 1 minus H. Okay, or they use BG. Okay, BG. will be minus 31H. Okay, great. So hence line of BG is R equals to, you can use OB plus lambda. Okay, maybe just use OB plus lambda or T, BG, because it's a direction. T is real value. Then this is R equals to, that's it. That's how you do this part here. That's all. Okay. Let's look at the subsequent. So I'm just going to share a few ways of doing part two. Part two, memory. Okay. We're just going to go through a bit. So if you're using line and line is cosine theta, dot product but cosine theta, if you want to memorize it. Because now it's about cramming as much information as you can, right? So angle between line and line is cosine theta. Angle between planes and planes is also cosine theta. But it's dot product. Angle between two planes would be sine theta instead. Okay. So just this one, just take note. So once this is done, what we're going to do is you find the sine angle between BG and rectangular B. This is a plane. ABCD. Now, the normal of ABCD, some of you may not know what's the normal of ABCD. Yeah? The normal of ABCD is just normal of ABCD. Just 0, 0, 1. Okay. You don't need 0, 0, H. This normal of ABCD here is pointing upwards, right? This one pointing upwards, right? This is just 0, 0, 1. Any direction parallel to it, ABCD is just 0, 0, 1. Okay. Heck, I could even write down the equation of ABCD out. You know what's the equation of ABCD? Plane ABCD, right? It's just R dot 0, 0, 1 equals to 0. Okay. So just take note. If this is 0 means contains origin. Okay. So pi ABCD is just R dot 0, 0, 1, 0, 0. Anyway, this is actually the what we call the XY plane. Okay. You may want to copy it down somewhere. So XY plane, you need to know that is R dot 0, 0, 1 YZ plane is R dot, because it all passes through the origin, 1, 0, 0 equals to 0, and then after that you have got the YZ XZ. Okay. Don't need to memorize if you understand how it's being derived. I gone through many times why these are so. You really don't need to memorize it, but just understand it can really. Okay. Because all these planes passes through the origin, that's why it has a 0 here. All these planes here passes through the origin. Okay. And the normal can be easily deduced by looking at the graph that you're dealing with. So actually the plane ABCD can be quickly written down as R equals to 0, 0, 1, 0. Okay. Then the sine angle between BG, which is this one and this one, right? So you could actually very quickly use sine theta equals to D dot N over mod D mod N. The sine angle will just be this. So actually this is a pretty fast way to do it. So this is method 1. So this is this is like a brainless way of doing it if you want to do it quick. So this is like that. This will be modulus modulus. That's okay. Then this will be h over square root 3 square 10 h square. Okay, that's how you do it. Yep, sine theta. Now the method 2 will be just using trigonometry. So method 2 is just geometry. Essentially, if you want to find sine theta, you just remember this one is like that. You use sine theta. If you can visualize it, it's good. Sine theta is here. So essentially, it's something like sine theta is equals to height over bg. This is this is much faster. This is much faster. So you use by geometry if you can visualize, like your EMF stuff, right? You what you do is you just write height over bg. That's so you can see this are the height over bg. This triangle here, height over bg will give you a sine theta here. So that's a pretty dope. I think it's a pretty cool one as well. So you just use bg and you just h over bg. Actually, this is much faster, man. This is like cheat code to the max. 3 square. Okay. Hey, I'm showing you all this method not because you should prefer one to the other, but to help you to think in a geometrical way and also in a vector way. They are all interrelated. So whichever you want to stick to, right, just stick to. But method 2 seems very enticing to me. I'm gonna stick to method 2. Method 2. You okay? You understand what I'm saying? You understand? Given the height is 6, but if you're too confused with that, right, what I would suggest is you just draw a plane like that, because it's a plane equation, B, C, F, G. Okay, you already have got B to G lah. You have B to G, right? After which you just need, actually what you need is just B to C. Yeah. Okay, what's the fastest way to find B to C? Actually, B to C is just this one. It's just this direction, I. Do you know how to see this? Okay, I repeat. B to C, right? Okay, you can find the coordinate of C, not an issue. Coordinate of C is actually just 4, 2, 0. Okay. But I'm telling you B to C, this direction here, is just parallel to 1, 0, 0. You can just, if you don't believe me, you can just take OC. You get, okay, never mind, I'll just do the OC. So this is 420. You eventually get 100. B is actually 4 minus 20. So the direction here, B to C, is parallel to oh, sorry, it's 0, 1, 0. So this is 0, 1, 0 parallel to this direction. 0, 1, 0, not 1. This B to C will just be 0, 4, 0, which is actually 0, 1, 0. B to G you have, right? B to G is minus 3, 1, 6. 1H. So minus 3, 1H. But H is given. It's 6 units now. That is pretty okay. So normal. I like it when there are a lot of zeros. It's very fun to play. It's like 6, 0. Normal. So Normal of the plane. So just key in. Okay, I will suggest you use 2 points. Use then test, just check. This is okay. You check like that, you will get the correct answer. So as in this Cartesian form, right? Cartesian form. Okay. Shortest distance A to B, C, F, G. B, C, A to B, C, F, G. That's pretty okay. So part 4. Don't really care lah. B, C, F, G, right? Because now B, C, F, G, the normal is 2, 0, 1. Don't look at the diagram. The look at the diagram is very confusing one. So you just put an A here. A is shortest distance. A is read your A. A would be -4. -4 here. Then -2, 0. -4, -2, 0. So -4. This is a normal. Okay. If you want to find the shortest distance A to the plane, you need a point on the plane. You have many points on the plane. You have B or your C. Just pick one. Use 4 -2, 3 also can. 4 -2, 0 also can. 4 -2, 0 is there. So this is a B. What you do is you just do this line here. You want this side here. So this length and this one, sandwich between them. The length that you want is the adjacent side. So dot product. Okay, just dot product. So this will be AB dot with n unit vector. That's about it. This is you should know how to do this. This is like should know how to do it really. This is so this is 16. Yeah. Just leave it like that. Fine. We've done this many times now, so no need to explain. Okay, the first thing is to understand that essentially, right, M is just the foot of perpendicular. Okay, so yeah. Let's see how we can do this. M is foot of perpendicular. Right, so what we need to find is what is M? So we try and figure out what does this mean? BM. Where's BM? A to B. A, B, C, B, C, F, G. Okay, great. So this, now take note of this. Please take note here to here. Okay. Now what we need is essentially this short. This is M here, right? I'm not sure where's the. It may be somewhere else. I'm not sure. It doesn't have to be that point there. So this is M here. Actually, if I have A, B, C, they want the shortest distance of M to the rectangular base, right? The shortest distance will just be actually the C. This C here. This C will give you the height of M. That's the shortest distance, right? That's the shortest distance. So since you want to use the previous way of this will be the height lah, be height, or yeah, that's the height that you need to find. Since you want to use the previous one, so meaning to say you just find the coordinate of m. That's the main thing. You need to find the coordinate of m. But how do you find the coordinate of m? That is the annoying thing, because now you need to see whether this is an acute angle or this is actually acute or obtuse. If it's obtuse, meaning the normal is pointing downwards. If it's acute, meaning the normal is pointing upwards. Okay, so I repeat, because now you're using A to B, right? And then after which you A to B is here, and after which you dot n, n is here, right? Actually, you should use B to A. Sorry. If you take B to A and dot at, and because I'm assuming n is pointing upwards, if this gives me a positive dot product, meaning it is acute. If dot this, meaning to say, just look at the dot product here, it is obtuse. Okay, so this is actually quite important. So I'll repeat again. You try and take B to A instead of A to B, because now the angle is important. I repeat, so what I'm going to do is I'm going to take B to A, because I drew B to A, right, on the diagram. This is B to A. This is B, this is A here. So draw B to A is here. Use exactly B to A would be minus 800. Then normal, I'm assuming, is pointing outwards, so it's 201, right? So this case here, actually what happens is if you take A to B dot with 201, this would be minus 200 dot with 201. This is actually negative 16. Negative 16 meaning to say it's actually obtuse, no longer obtuse. It's actually this angle here. So actually this normal is pointing downwards. I repeat, this normal is pointing downwards. Okay. Now why this is important? Because if you do not know where is it pointing, you can't possibly find the length there. Okay. Obtuse. So this one is like that. Okay. So this is important. Okay. This part is going to be confusing. Okay. This part is going to, no. You're supposed to use part 4. You're not this is the only method you can get the marks, okay? Because of the phrasing, right? This is the only method. There's no other way you can do it really. This is only, if you do anything other than this, right? Meaning you don't get the marks, because the part is use your answer in part 4. If you never use the answer in part 4, you can't, okay? Meaning to say you need to use this one, somehow use this length here, okay? Okay, I'll explain again, Mr. Gan, could you explain again? Okay, Kate. I understand this part here is confusing, So, start off with I'm going to explain again this part because this is confusing. Let me explain again. Okay, we have a plane here. Okay, let me explain. We have a plane here, and then this part here, we have a B and we have a A. Now, part 4, we know that this distance here, this M is what we want to find. We know that this distance here is 16 over root 5. Take note of that. So in other words, right? Okay, let me tell you what you should do. You should actually do B, this direction here. So you want to find OM, right? Now you want to find OM. So if you want to find OM, what you could do is you just find AM. So OM is actually OM is actually OA plus AM. Agree? Secondary school stuff. Now, OA, we already know what is it. Okay? AM is actually 16 over root 5 times unit vector of AM, A to M. Okay? This unit vector here. We need to take a unit vector. Unit vector is direct proportion. So we need to take like one unit vector. Okay? Now this one unit vector, how to get? The question is how to get this unit vector. This unit vector here, we can take the normal. Okay? The normal. So, but the question now is the normal pointing outwards or the normal pointing downwards? That is the question. Okay. Because without knowing the direction, you do not know whether you should add or you should minus. That is the problem. Okay. So I repeat, you want to use the unit vector of the normal, but you do not know whether the normal is pointing upwards or pointing downwards. That is the question. Okay. So my proposition is very simple. To know whether it's pointing upwards or pointing downwards, simply just take BA, which is actually BA, not AB. I use AB here. So use BA, meaning to say 800 here. Okay, this is 800, this direction. And you assume that, okay, then you just take BA 00, you dot with the normal. The normal usually you assume is on top, correct? So this is 201. Is it correct? 201. BA is minus 88. BA is minus 800. And this will give you minus 16. Okay, because this is cosine. This meaning cosine theta is 0, meaning to say it's actually an obtuse angle. If it's obtuse, right? Okay. If it's obtuse, the normal is not converging with the back direction because this is acute, meaning to say the normal is actually pointing downwards. Okay. You need to decide the normal pointing downwards by doing a dot product without modulus, because if it's negative, it will tell you it's obtuse. That is the first thing you need to do. So, is that okay? If not okay, review this video again, okay? Because we really don't have much time. So once you do that already, you take the length of 16 over root 5, you times the unit vector of, okay, so we know that this is actually n, right, is parallel to am. It's actually pointing downwards, okay? So this will just be the am, the unit vector of am is equals to n unit vector because they are parallel. Any parallel vectors, the unit vector, the chop off one unit is exactly the same unit that you are looking at. So in other words, this would just be um, unit vectors is 201 over square root 2 square plus 0 square plus 1 square. So this will be 201 over 5. So this OA, what's OA? OA is actually OA is actually we want to find AM, right? A to M. A to M. Or A. OA is minus 4 minus 20. Okay. Plus 16 over 5, 201. So this one would probably be, my goodness, this is not fun. Minus 4. Okay, so this one is, okay. So OM is 16 over 5. OM is 16 over 5. In other words, I could find my H. OM is 16 over 5. So the height Z coordinate is the, okay, that's it.